Hello class, this is your Unit 3 lecture. Before we hop in, I want to make you a suggestion, and my suggestion is that you make sure that you're not just forgetting about the stuff from weeks 1 and 2. As I mentioned before, this information builds on each other, and again, we really want to make sure that we help you build your confidence as you leave this class for your future work, because there are different concepts from this class that will be helpful in your future. And so again, if you haven't had an opportunity, maybe you're just kind of getting your bearings about yourself, we're halfway through the class, maybe this is when you go back and you print some of the document so that you can have it in front of you. And you notice here that I say that this particular handout that I'm going to review with you today provides some key academic vocabulary, and they're basically student-friendly facts because I want to make sure that you have like very detailed work examples and language that you can understand. So I hope that you find this helpful. As always, we start with our academic vocabulary, and so a lot of what you're going to probably see in the work this week is products and quotients, dealing with radicals, and even some quadratic equation type things. And so I'm going to orient you to that. I also wanted to just share with you, it's super important that you're following along in your online textbook. And so that Alex McGraw-Hill textbook, you have your assignments there, but the chapter readings and those tutorials are super important as well. Really, all of these different things like my video and the other materials, it provides you a solid toolkit or a strong toolbox to be successful, because we're not in class working problems every single day together, and so it's important that you really work on your own toolbox. And so I'm trying to connect those materials with you, and Alex has those tutorials that go in lockstep with each assignment. So let's look at some of this new vocabulary. So the ones that I really want you to focus on, for example, is radicals or your root, because that's a pretty big thing this week that you'll see. And so essentially your root or your radical is your expression of the form of that kind of elongated V. So you'll see that square root sign with the X. So for example, the square root of 25 equals 5. This might be something that you're familiar with. I hope so. The square root of 25, I think, is a simple example to start with. So essentially this is a radical where we're dealing with roots. And so that could feel complicated until you look at the sample and be like, oh yeah, the square root of 25 is 5. Why is it this 5? Because it's a number that times itself is that in number. So 5 times 5 is 25. So that means that the square root of 25 is 5. And so, sometimes we can get mixed up in the vocabulary, but I just wanted you to be able to see radical is the root, and then the radicand is your number or your variable that's under it. Typically, you won't see this vocabulary used too often outside of radical or square root. You will see down here simple radical form or perfect square. Perfect square is used quite often. And so just pay attention to those ones that are going to be in your problem. And the way that you can do that is, again, having this printed as you work those problems. A perfect square is anything that basically the square root is an integer, right? So like 4 times 4 is 16, and so that's a perfect square. Remember, we talked about absolute values previously, so hopefully you've got those absolute value notes handy. And then one thing you're going to be asked to do this week is rationalizing denominators. That should show up in some of your assignments. And so I wanted to give you the key terms that deal with the rationalizing of denominators, and then we'll look at a couple of samples. Another part, like key vocabulary that should be familiar to you, monomial and binomial. Remember, we just got finished talking about that last week. Single is monomial, 2 binomial. And then your goal really when you're solving is that you have no radicals in the denominator and the fraction is simplified. So remember I told you you're not always solving for a number, you're solving for an outcome, and you have to understand what that outcome is. And so when you get past that entry-level work and then you get into the quadratic equations, here's some different terminology that will help you with your quadratic equations. I personally think that before you even start solving any of the assignments for quadratic equations, I would read through that chapter in the ALEKS textbook and maybe Google Khan Academy quadratic equations and just watch them solve several problems. I'm just giving you a minute to read here. So essentially the quadratic equation is an equation of the form which is a times x to the second power plus bx plus c equals 0, where a is not equal to 0. So your standard form with a quadratic equation is this. And let me just highlight that right there for you. So if you check that standard form out, that's what you need to become familiar with, okay? Anytime we say quadratic equation, this is it. So that's ax to the second power, okay? Remember, it's the little tiny 2 above the x. That's what it would look like if you were handwriting this. So this is your standard form. This is what you're going to be familiar with. And then when you're factoring, you're going to write the quadratic as a product of the binomials and use that zero product property. Again, it's here for you, but you'll be reminded that I've given you some of this vocabulary previously. So really understanding these standard forms and these formulas here is going to be helpful before you get started, and then looking at some samples. I think that will reduce your frustration. Here's another couple of hints for you as you solve. And then we're going to get into the examples, okay? So if you have, I actually put the instructions here for these examples because what I figured you could do is either go on Khan Academy or in ALEKS and look for additional examples beyond just the ones that I'm going to give you, but also when you look at the instructions for your assignments this week, you can compare the instructions. So for example, if you see instructions that's asking you to simplify using product and quotient properties, then you can find these examples because there's many different examples within this topic, so you want to find the one that's similar to what you're solving online in your assignments. And so how do we simplify the square root of 72? How do we simplify the square root of 50 over 8? How do we simplify 3 square root over 18x to the third power? Well, let's look. The first thing you're going to do is part 1. You're going to factor 72 out to 36 because 36 is a perfect square. Why is that a perfect square? Because 36 times 36 equals 72. So when you write that out, you'll put the square root sign over 36 times 2. And then if you remember our properties, you're going to put the square root of 36 first and then your square root of 2 first, right? So it's this times this, this times that. So it's the square root of 36 times the square root of 2, which equals 6 times the square root of 2. So your final answer is 6 over the square root of 2. That's as simple as you can get that. So I'll give you a minute to just look at that. So that's the number 1 example here. Now let's look at number 2, the square root of 50 over 8. Well, the first thing we have to do is reduce that fraction because 50 over 8 we know can be reduced. That should jump out to you because 50, it probably will jump in your head. Well, I know I can reduce it by 2 because 25 and 25 is 50. So that keys you in right there. You know you're going to be able to reduce that. And most people are familiar with 8 being able to be reduced down to 4. So the first thing you're going to do is reduce. Again, try not to get so caught up on the end result. Just follow the steps, right? And again, we have our steps back up here in our vocabulary. Then you're going to use that quotient property. So again, where are you going to go find your quotient property? clear, right? So that's why it's helpful to have this in front of you, especially if you're on a computer screen and you're trying to use the vocabulary and the steps and your problem that you're looking at as well. And then you come to your final answer after using the quotient property, where you've got the square root of 25 over 4 equals the square root of 25 times the square root of 4. Remember when we have like this, any kind of symbol here, and then you have 2 inside the parentheses, this is going to be multiplied times the first, and then it's going to be multiplied times the second. So you've got the square root of 50 times the square root of 8. And so you're going to end up with 5 over 2, because 5 times 5 was 25, and 2 times 2 is 4. So that's simplified. This third one I'm not going to go through with you. If you do have any interest in going through some very complex examples, you can. I don't think you're going to face too many complex examples such as this week, but these first two for sure will be helpful. And then if you're asked to rationalize the denominator, here's what you're going to do. You're going to rationalize and then simplify. So here's the problem, and then here's your detailed solution. So you can see that it's broken down by parts. So the first thing you're going to do is multiply your numerator and denominator by the square root of 3, because that's going to clear out your radical. If you're like, oh my God, Dr. Delmar, I don't remember what a radical is, go back to your vocabulary. I hate to beat that dead horse. And then you're going to use the conjugation of use the conjugate of the denominator. What's the conjugate? What's the denominator? Go back to your vocabulary. Then you're going to multiply. You're going to work with the numerator and then the denominator, and then you'll have your results. Again, here's your final answer. It's not a number, right? You're just coming up to your simplified expression. Solving basic quadratic equations, that will definitely come up this week. As you recall, this is the typical standard format. Again, multiple steps, so if you just take your time and go step by step, you'll be able to work these problems. So what's the first thing we're going to do? We're going to look at factoring. So we're going to look for two numbers that multiply to positive 6 and add it to negative 5. And those numbers are negative 2 and negative 3. Just highlighting that for you. Then you're going to apply that zero product property. Again, oh my gosh, Dr. Delmar, what's the zero product property? Again, go back to your printout of your academic terminology or vocabulary. And then you have your solutions. Pretty simple, right? X minus 2 is going to equal to 0, or X minus 3 is equal to 0, and that's the answer. Because when you move that negative 2 to the other side, it becomes a positive, and when you move that negative 3 to the other side, it becomes a positive. So when you subtract 3 from both sides, you're going to actually end up with x equals a positive 3, or here x equals positive 2, because you moved it over to the other side of the equals. Now you could also use the quadratic formula, which is there for you, but I'm going to leave it with the simplest part because I don't want to confuse you too much. I'm just going to use it with the factoring method because I think that's the method that you should use most often when you're able to. Some of you may be able to understand the more complex math. That's certainly fine, or some of you may want to do some additional videos and studying of your chapter before you engage with that quadratic formula. All right, well, I'm going to save this, and I look forward to moving into week 4 with you. You're almost there. You're almost at the finish line, guys.